Alright, today we are graphing linear inequalities, but the second thing we're going to look at is actually graphing these inequalities now. So we've got two variables, we've got an x and a y, so we're going to use, just like we would use point slope to graph a line, we're going to have lines here, but they're going to be inequalities, so we're going to have shading involved because there's more than one answer to what's happening. So I have the equation x plus 4y is less than negative 12. So the first thing that we're going to want to do is solve the inequality for y. We want it to be in y equals or y less than equal to greater than equal to form, so that way we can actually graph it. Remember that if you multiply or divide by a negative, then it's going to flip your symbol. Okay, so we're going to solve for y. First thing we want to do is subtract our x. So we're left with 4y is less than, we can't combine these, so negative x minus 12. Get y by itself, so we divide everything by 4. I like to do each piece by 4 so that way we can see our slope and our y-intercept. So that gives me y less than, it was divided by a positive, so our sign stays the same. Negative x over 4, the same thing as negative 1 over 4x, if that helps you to see your slope. Negative 12 divided by 4 is negative 3, so we have minus 3. The second thing you want to do is we want to actually graph that inequality. If you remember back from Algebra 1, to graph, we're going to plot the y-intercept and then count your slope, which is always rise over run. Okay, so we're going to come in to our graph. My y-intercept is down here at negative 3. So we're going to plot our point at negative 3. My slope is negative 1 over 4. So that means down 1, right 4. So from that point, we're going to go down 1, right 4. Down 1, right 4. You can also go up 1, left 4. So you can go the opposite, up 1, left 4. When you look at it, your point, since it's a negative slope, your point should be going down in a negative fashion. Okay, the things that change on an inequality is the type of line we have is determined by the symbol that we have. So if you have a less than or a greater than, you're going to use a dashed line. Okay, because this means it comes close to those, but it does not actually include those values because we don't want it to be equal to. If you have a less than equal to or greater than equal to, you're going to use a solid line. Oops. Okay, so it'll be dashed if it's just greater than or less than. It'll be solid if it's got the equal to because it includes those points. Since we just have a less than, we're going to use a dashed line as we draw. Then the next thing that we need to do is decide our shading because we're looking for all of the possible coordinate points that satisfy this inequality. So step number 3 is shading. The most efficient way that's going to get you the correct answer each time is to plug in a point. Just like we did first where we want to decide if something is a solution, we're going to choose a point, plug it into our original inequality, and we want to decide whether or not that's going to be a solution. I try and always plug in the point 0, 0. The only time you cannot plug in the point 0, 0 is if 0, 0 is on our line. So the point 0, 0 is not on my line, so we're okay. If 0, 0 is a point on your line, if your line goes through the origin, then just choose another point that's easy to plug in. 1, 1 or 1, 0, something that's not on your line. For the most part, you'll be able to use 0, 0. Okay, so you're going to plug it into the original. The reason you want to use the original is in case you've made mistakes somewhere along here, you're still going back to the original one, and a lot of times your x and y are on the same side. It just makes it a little bit easier to work with. Okay, so you're going to plug it into the original. If you get yes, so if you plug it in and it works, it is a solution, you're going to shade the side with that point. So if you did 0, 0, you'd shade the side with the point. If it's no, you're going to shade the other side. Okay, so if we look at this point, we're going to plug in 0, 0. Okay, this is where I'm plugging it. Right there at 0, 0, I'm plugging that point in. So we go back to my original, which was x plus 4y is less than negative 12. So we plug in 0 for x and 0 for y. 0 plus 4 times 0 less than negative 12. Well, 0 plus 4 times 0 is also 0. 0 plus 0 is 0. Is 0 less than negative 12? No, it's not. So since right here at 0, 0, it's not. I'm going to write no over that point. This is kind of your built-in dummy system. Do you want to shade the side where it says no? Well, no. You want to shade the other side. So since 0, 0 is not a solution, we're going to shade everything on the other side of my line. Okay, so we shade the opposite side. That's saying any point down here in the shaded region that I choose, any point, if I plug it in back to my original, it will be true. So any point down here that I pick, when I plug it into the original, it'll make a true statement. And that's how you go. So your steps again, solve for y, graph it like you would originally. If it's got a less than or greater than, not equal to, you've got to use the dashed line. Otherwise you use your solid line. Then you need to decide your shading, plug in a point. 0, 0 is the easiest to plug into, but you can choose whatever point you want. If it's yes, you're going to shade the side that has 0, 0, or whatever point you plugged in. So if it says yes, you'll shade over the yes. If it's a no, then you're going to shade the other side. So that yes or no is going to kind of tell you what to do.